Okay, good day, grade 9s. Good day, grade 8s. I trust you're well. Today we are just going to recap on some of the topics for paper 1, section B. Remember, there's going to be 5 topics. The first topic is number patterns, numeric and geometric patterns, right? So that includes geometric sequences, arithmetic sequence. You need to know how to find the general rule, etc. Right? And the next section is algebra. So it's going to be algebraic expressions and algebraic equations. Right? The third section is going to be functions and relationships. So basically functions and relationships. And the last section is going to be on graphs. So graphs is actually quite an interesting section because you have to know how to interpret global graphs. You also need to know how to plot coordinates onto the Cartesian plane. Very, very important as well. Okay, so moving on from there, right, let me just clear the screen. Moving on from there, let us look at some algebraic equations. There's one algebraic equation that is quite interesting, and that is, let me just get this right, and that is an exponential equation, right? And then let's look at an example of that, an example of an exponential equation. So as the name suggests, the variable is on the exponent, right? So for example, if I have 2 raised to the power of placeholder is equal to 2 raised to the power of 2, and I ask you what is the value of placeholder, what number should go in the place of placeholder. Now obviously your response should be that the placeholder is 2, because 2 raised to the power of 2 is equal to 2 raised to the power of 2. Now in high school we do not use placeholder, we use a variable like x, like y, like a or b, right? So if I have 2 raised to the power of x is equal to 2 raised to the power of 2, because the bases are the same, it implies that the exponents will be the same as well. So therefore it implies that x is equal to 2. And that is how I solve an exponential equation. Now let's look at an example. Right? Let's look at an example of this. Right? So I'm just going to clear the screen. As such, right? Now let's look at an example. Let's say I have 10 raised to the power of x plus 1 is equal to 100 raised, or just 100, right? So I have 10 raised to the power of x plus 1 is equal to 100. Now if I look at 100, right, I can write it in exponential form. I know that 10 raised to the power of x plus 1 is equal to 10 raised to the power of 2, because 10 raised to the power of 2 actually means 10 times 10, which is equal to 100. So I can rewrite 100 as 10 raised to the power of 2. And now since the bases are the same, I can equate the exponent. So I can say that it implies that x plus 1 is equal to 2, and I can solve this equation as I would any linear equation. It's x is equal to 2 minus 1, therefore x is equal to 1, and that is my final answer. So that is how I solve an exponential equation. You should know how to solve equations involving the distributive property, for example, and so forth and so on. So you can study through that when you have time. Now, that being said, I'm just looking at the important things for this video. Right? So that being said, let us look at algebraic expressions, right? Algebraic expressions. Okay, there we are. Right. So let's say we are required to simplify this. We are required to simplify the expression 3a raised to the power of 5, and I have negative 2a raised to the power of 4 all over 2a raised to the power of 3, right? And I'm required to simplify this algebraic expression, right? How many terms are there in this algebraic expression? There's one term. This is regarded as one term. So to simplify this, the first thing I need to do is simplify the numerator, the top part of the fraction. So if I can read this, it's actually 3a raised to the power 5 times negative 2a raised to the power 4. So 3 times negative 2 is negative 6. A raised to the power 5 times a raised to the power 4. Now, although this is paper 1 section B, you still need to know the content from section A as well, especially the laws of exponents. When multiplying and the bases are the same, we keep the common base of A and we just add the exponents together. And we are multiplying in this case, so it's going to be a raised to the power of 5 plus 2 all over 2a raised to the power of 3, right? So negative 6 divided by 2, that's negative 3, right? And of course, this is just 9. So it's going to be 9. Actually, let me just write it out so it's more better. So it's negative 6a raised to the power of 9 over 2a raised to the power of 3, right? Which is equal to negative 6a. I'm repeating myself here. So negative 6 divided by 2, that's negative 3. And of course, in this case, I can apply the second law of exponents. When dividing and the bases are the same, I subtract the exponents. I keep the common base of a, and I start off with the first exponent minus the second exponent, which is equal to negative 3a raised to the power of 6. And that is my final solution, right? And that is my final solution from there. Now, let's look at another example. Okay, let's look at another example. Let's say I'm required to simplify the following. Let's say I have a squared minus a all over a plus 5a squared plus 10 all over 5a. And I'm required to simplify this. First of all, we need to bear in mind how fractions work. For example, if I have 1 over 4 plus 2 over 4, because the denominators are the same, the solution or the sum will have the common denominator 4. All I can do is just add the numerators. So it's 1 plus 2 all over 4, which will be 3 over 4, right? Now, the opposite is also true. If I'm given 1 plus 2 all over 4, I can split this into two fractions. Remember, this is one term. Now I can split it into two terms, 1 over 4 plus 2 over 4. A term is separated by either addition or subtraction. So looking at this question, there's two terms. This is regarded as one term, and the second term is here, the one that I'm circling. So this is equal to, now for the first term, I'm going to split this up into two fractions. A squared divided by a minus a over a plus, right, so let me just write the plus like that, plus, now I can split this term into two fractions as well. It's going to be 5a squared over 5a plus 10 over 5a, right? And now I can calculate that accordingly. I can use the second law of exponents to simplify each term. There's four terms here. A squared divided by a will just be a. Remember, it's a raised to the power of 2 minus 1. There's an invisible exponent of 1. Minus a divided by a is 1. Any number divided by itself is 1 except for 0. 0 divided by 0 is undivided. Plus 5 divided by 5 is 1. A squared divided by a raised to the power of 1 is a raised to the power of 1. Plus 10 divided by 5 is 2, right? And the denominator in this case will be a. No, actually, I just missed out an a in this question here. Let me just carry that forward. Apologies for that, right? And the a and the a should divide off, actually. So what am I left with? I'm left with a minus 1 plus a plus 2. So now I look for like terms. A plus a is like 1 apple plus 1 apple. That's 2 apples. That's 2a. Negative 1 plus 2. That's plus 1. And that is my final answer. 2a plus 1. I cannot simplify that any further, right? Last thing I wanted to quickly discuss with you is functions, right? Functions. So if I look at a function, A function is basically an input to an output. What do I mean by that? Let's say I have a diagram that looks something like this. Right? Let's say I have a diagram that looks something like this. Right? I have 5x and I have plus 2. Right? And it all connects to this diagram. Right? Let's say I'm given that this is 1, 2, and I'm given that this is 52. Right? So how can I find the output values? Now, assuming that these are the values of x, these are the values of y, because that's what a function is. It's the relationship basically between your input and output. So 5x basically means 5 times x. So 5 times 1 is 5, 5 plus 2 is 7, 2 times 5 is 10, 10 plus 2 is 12. And now in this case, it's quite special because I'm given the output. I need to use inverse operations and work backwards to find the input. So what is the inverse of addition? It's subtraction. So I'm going to say 52 minus 2, which is 50. And instead of multiplying by 5, I'm going to divide by 5. So 50 divided by 5 is 10. Please do not do this. This is absolutely incorrect. Because why? BODMAS has been applied. They're going to do division. So use brackets here. Right? First, say 52 minus 2, which is 50. And 50 divided by 5, which is 10. Right? And of course, as I said, graphs are also quite an important part in your paper. Please learn how to plot graphs onto the Cartesian plane, etc. Right? Thank you, grade 8s. I wish you all the best.